So we've now been talking about trig functions, and with trig functions we can only use them, and we can only use SOHCAHTOA if we have a right triangle. So we're now going to talk about something called reference angles, which is going to allow us to use trig functions on angles that are not right angles. And we're going to do that by creating these reference angles. So when we talk about a reference angle, in your book it's referred to as theta prime, and I'm going to try really hard to call it that. I've always referred to them as theta r, so I want to put both of these in here. So if all of a sudden I say theta r and don't realize it, and you're going, what is Miss White talking about? That's what. So a reference angle, if we have theta as an angle in standard position, the reference angle that we're going to call theta prime, or theta r, is going to be the positive acute angle formed by the terminal side and the x-axis. So I'm really going to point out the important things. It's a positive acute angle, and it's formed with the x-axis. Okay? So in quadrant 1, if this were my theta, notice that my theta forms an acute right triangle, or can form an acute right triangle with the x-axis. So in quadrant 1, theta and theta prime, my reference angle, are going to be the same. However, notice in quadrant 2, if I start from my standard position, meaning I'm starting here at 0 degrees, and I rotate and stop here having this obtuse theta, I cannot turn that theta into an acute angle. It's an obtuse angle. So instead what I'm going to do is I'm going to take my terminal side and I'm going to make this right triangle as my acute angle right here. And this acute angle is going to be my reference angle, theta prime. And again, I'm making that acute angle with the x-axis. Similarly, in quadrant 3, how did I get there? I started in standard form and I rotated all the way over. There's my theta. I cannot make an acute right triangle with the x-axis using that angle. However, if I take my terminal side and go up to the x-axis, notice that, and let me try to change colors here for this one. This little angle right here is going to be an acute angle made with, again, the x-axis. So that is going to be my theta prime. Finally, if I rotated from standard position down to quadrant 4, then this, again, cannot be turned into an acute angle. But notice if I were to take my terminal side and go up to the x-axis, that was a little excessive, go up to the x-axis, notice that this angle right here is an acute angle with the x-axis, so that's going to again be my theta prime. So from here, let's go ahead and look at how we're going to find some reference angles given some angled measurements. And I will say that with the app that I use to make these videos, my degrees come out kind of funny looking. So this is 120 degrees for letter A. So first thing I'm going to do if I'm asked to find the reference angle is I'm actually going to graph the angle I'm given to figure out what quadrant I'm in. Well, I know that this is 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So 120 degrees is going to be somewhere in here. I don't have to be real accurate. Okay. Well, notice at 120 we're running into that issue that it cannot make an acute angle. But notice that here, if I use my terminal side, I can make an acute angle with the x-axis here. Let's call that theta prime. Well, how am I going to figure out what that theta prime is? How am I going to figure out what my reference angle is? Well, look at what I know. I know this whole thing is 180, and I know this much of it is 120. Well, if I take the whole thing and I subtract 120, shouldn't I be left with this a little bit here, this reference angle? So I'm going to say that my theta prime is 180 minus 120, or 60 degrees. So let's look at the second example, part B. So I'm going to do the same thing. I'm going to start by graphing it. And I'm negative this time, which remember means I'm going to go clockwise. So it means this point is going to be negative 90. This will be negative 180. This will be negative 270. My 7 looks a little weird. So I'm going to be somewhere in here. Again, it doesn't have to be exact. This is my theta. I cannot make an acute right angle with my x-axis with this theta. I can make it with my y-axis, but the rule is it has to be my x-axis. So I'm going to go ahead and say, but hey, I can take my terminal side and I can make an acute right angle right here. So this is going to be my reference angle. Well, how am I going to find that? Well, if you look at the definition, it says it has to be positive. So rather than talk about all these negatives, because I'm going to have to get a positive angle anyway, I'm going to go ahead and say this whole distance is 180. This whole distance is 180, and this theta is 150. Even though I went back 150, the actual distance I traveled is 150. So 180, 150. How do I find this small piece? Well, just like in example A, couldn't I say 180 minus this 150 is going to leave me with this small piece of interest? So I'm going to say here that theta reference is 180 minus 150, and I get 30 degrees. And that's going to be this theta reference angle here. Okay. Let's look at 2 more examples with this. Slide this down a little bit. And I'm going to start with the same way. So I'm going to start by graphing what is 42 degrees. Well, I know this is 90, so I'm going to be somewhere in quadrant 1. Well, guess what? This theta here of 42 degrees, I can make an acute right angle with the x-axis by coming down right here. So I don't have to worry about a reference angle. In this case, my reference angle is equivalent to my given angle. I love when that happens. So now let's look at example 3. On example 3, I'm going to go ahead and I'm going to start the same way. I'm going to start by making my given angle. So I know this is 90, this is 180, this is 270, this is 360. So I start here, I come all the way around to somewhere in here. Again, I cannot make an acute angle with my x-axis. So I'm going to go ahead and I'm going to make a right angle with my x-axis, an acute angle, right triangle, right here. And I should switch colors for that. Right here. So this is going to be my reference angle that I'm going to be looking at. So how am I going to find that reference angle? Well, I know, this is really about just looking at your picture and figuring out how can I find the missing piece based on what I'm given. Well, I know all of this is 300 degrees. So all of this is 300, and I know the entire circle is 360. Well, how am I going to figure out this little bit if this whole thing is 360 and this much of it is 300? Well, I'm going to go ahead and subtract. 360 minus 300 gives me a theta reference angle of 60 degrees. So it's crucial, and I know sometimes we want just a quick fix on, well, can you just give me a formula? And they do give you some formulas in your book about what to do in each quadrant. The problem is the formulas don't always work when we have negative rotations. So I will often encourage my students that instead of relying on a formula, why don't we just draw out what we're given and then use some reasoning to figure out that missing angle that we really want to know, which is what I tried to do here on examples A through D. If you have any questions, please bring them with you to class tomorrow, and then we can go over them together. Oh, and before I end this video, there is one other thing I want to point out, and this is going to come up in the next one. The big reason we learn these is so that we can find sine, cosine, etc., all of our trig functions of non-right triangles, or non-right angles, or obtuse angles. So notice that sine of theta is always going to be equal to sine of theta r, sine theta prime. Cosine of theta is always going to be equal to cosine of our reference angle. Same thing as tangent, as well as cosecant, secant, and cotangent. And we will determine our sine by our quadrant. And like I said, that will be gone over in the next video.